All right, let's talk about software, not just about writing code that, works. We're diving into what it really means to be a craftsman, to build software that's actually professional, the kind of stuff that lasts, that's a pleasure to work with, and that doesn't just fall apart under a little bit of pressure. So, where do we even begin this journey? Well, it all kicks off with one kind of surprising number: 80%. Get this. That is how much time developers spend just reading code that already exists. Not writing new stuff, but reading old stuff. Yep, you heard that right. 4/5 of your job is basically being a code detective, not a code author. And that one little fact, it changes everything. It is the entire foundation for what we're about to get into. Every programmer has a style, right? A sort of personality that they leave behind in their code. And since we're spending all that time reading it, it is super helpful to know who you're dealing with. So let's meet a few of these code personalities you're definitely going to run into. Okay, first up, we've got the Cryptic Ninja. I am sure you've seen this. The code is super clever, super short, and yeah, technically it runs, but what in the world does it actually do? You have to sit there and mentally unpack this crazy one-liner just to figure out, oh, it's just a Fibonacci function. That's not good communication, it's a brain teaser, and it's a huge waste of time for the next person who has to look at it. Then you've got the complete opposite, the verbose novelist. Now, their heart is in the right place, right? They want to be helpful, so they comment everything, every single line. The problem is, the actual code gets totally buried in this novel of comments. You're forced to read a whole essay just to find one line of logic. It's just too much. And oh boy, then there's the chaos demon. With this one, all bets are off. Indentation is all over the place. Brackets are doing their own thing. There's just no structure. It's just messy. Reading it is physically painful. Your brain has to work so hard just to figure out the shape of the code before you can even think about what it does. It is just pure chaos. But finally, we get to the professional. And just look at that. It's so much easier to read, isn't it? The name, Fibonacci, tells you exactly what it is. The parameter, position, makes sense. Everything is lined up nice and neat. You can just look at it and instantly understand the logic. No mental gymnastics required. This is what we're aiming for. Code that's written for people, not just for the computer. So, okay, how do we get away from all that personality-driven mess and start writing code like a professional every single time? Well, it all comes down to building a solid foundation of good habits, practices that lead to software that actually lasts. This chart right here tells the whole story. It's why we have to care about quality from the very beginning. Look, if you catch a bug while you're writing the code, the cost to fix it is basically nothing. But if it slips into testing, the cost goes up. And if that bug gets out into the wild, into production, man, the cost just explodes. And we're not just talking dollars here. We're talking about wasted time, a hit to your company's reputation, and losing the trust of your users. So what's a simple way to improve quality right now? It really does start with the easy stuff. Just look at this. On the left, you've got this wall of text, the original horror, and on the right, the improved version. What's the big change? All we did was add some empty lines and give things better names. Seriously, that's it. Whitespace costs you nothing. Use it to break things up, give your code some breathing room. It's such a tiny change, but it makes a massive difference in how easy the code is to understand. Really, this all comes down to a handful of key ideas. Good code, it's simple, it's clear. It follows the team's rules, their naming conventions, so you're all on the same page. It's got a logical structure, and most importantly, it's written with that next person in mind, the one who's going to have to read it. A huge piece of this puzzle is just having the right mindset, and that's where defensive programming comes in. It's this idea that you should always write code expecting things to break. Don't just assume you'll get perfect data. Don't assume the network will always be there. You have to code like Murphy's Law is real, because in software, it absolutely is. If it can go wrong, you better believe it will. Okay, so having that defensive mindset yourself is great, but that's only half the battle, right? How do you make sure your whole team is on board? That's where we get to one of the most powerful tools we have, something that a lot of people skip over: peer review. And this is where you hear the big question, right? Why do we need code reviews? We've got tests for that. I've got my unit tests, my integration tests. Why do I need someone else looking over my shoulder? And hey, it's a totally fair question. But the answer? Well, the answer is in the numbers. Take a look at this chart. It breaks down how good we are at finding bugs with different methods. So unit tests, they catch about a quarter of the problems. Integration tests, where you see how things work together, better, around 45%. But then look at code inspections, an actual peer review. A whopping 60%. That makes it by far the single best way to find bugs before they get out the door. And if you're still not sold, check this out. This is a real-world number. When AT&T started doing formal code reviews, they saw a 90% drop in defects. Let that sink in. 90%. That's not just a small tweak. That is a total game changer. And this isn't just some old theory from a textbook. This is how the absolute best companies work. At a place like Google, absolutely nothing gets submitted to the main code base until at least one other person has reviewed it. It's not optional. It's a mandatory part of how they build software, because it flat out works. All right, so we've talked about writing good code and reviewing it. But what about that big 80% number we started with, the reading part? How do we actually get good at diving into a huge, maybe confusing code base that someone else wrote? Well, this is where we have to put on our archaeologist hat. This really shows the difference between how a beginner and an expert approach a new code base. A novice, they just start at the top and read line by line by line. They get totally lost in the details. But an expert, they start from the top down. They look for the big picture, they spot patterns, and they start forming ideas. Like, okay, I think this part does that. Then they dive in to see if they're right. The big takeaway here is you have to stop just reading and start investigating. And for that investigation, you've got two main tools, static and dynamic analysis. Static analysis, think of it like a grammar and spell check for your code. It scans everything without actually running it, and it flags potential problems. Dynamic analysis, on the other hand, is when you actually run the program and watch what it does. You're observing it in the wild to find bugs and see how it performs. You really need both of these to get the full story. So let's make this super practical. Say you get a bug report for a huge system, something like Redis. I mean, where do you even begin? You need a process. First, you find the starting point. Where did the command come in? Then you follow the trail to the function that handles it. Next, you look at the data it's messing with. And then you start looking for the usual suspects. Bad error handling, messy memory management. See, it's a methodical hunt, not just random guessing. Look, everything we've talked about, quality, reviews, analysis, it's all about avoiding one specific moment. A moment that leads to a phrase that I guarantee every single one of you has either said or heard. It's the classic line you hear when a developer is backed into a corner. Famous. Last words. Because being a professional isn't about getting it to work on your machine. It's about building things that work everywhere, for everyone. And you only get there through discipline, teamwork, good standards, and treating your code like a craft. That right there is how you go from just being a coder to being a real software craftsman. Thanks for joining me.